He might as well vacuum for me then.
Yeah. Does he just not plan to take the test?
Correct.
Oh, yeah, he paid his money.
He already paid his money. Well, I am not responsible for his chapter 6 test. He's just aiming for 50%, of which I'm thinking you kind of got to be here for that. But, that's me. Okay. So. Yeah, I think that you cannot fail a class and walk at graduation.
I can.
It's not a required class.
Even like freshman year, if you like
No,
fail, like,
no.
class.
I think that if you fail this semester, I don't know if you're allowed to walk at graduation.
Really?
I don't know.
If I failed,
We are.
Oh, you are?
I
Okay.
just make sure because I'm failing.
Okay. What?
Are we not continuing for yesterday?
Oh,
We are.
Oh, I thought it was
Okay.
I didn't know you could fail.
So let me see if I can make your life slightly easier because I know
Can we just get rid of the other one that we were doing that was like...
No, I want you to hold on to it. We're going to come back to it. Okay? So, Remington, stop talking. Okay, so let's say we're going to start. I'm just going to give you a quick overview of the way I probably should have taught it to you in the first place. Sometimes you make decisions when you're teaching and you're like, oh, that was not a good decision. Should not have changed my mind about how I've taught it for 20 years. If I'm looking for the area between the x-axis and the graph there. This is what I was talking to you about making a slice the other day. What I want you to get in the habit of doing is drawing a slice that would represent one little rectangle of area. Okay? And the idea is that an integral adds up all of the little rectangles. Okay, that's the idea of a Riemann sum. Don't worry about estimations, just listen to me all the way. I want you to start making the slice because it will start to solidify when we switch directions to the other things that we're doing, okay? So even though you're like, I don't need that, I figured it out, just use the slice, okay? Because I will continue to refer to it and eventually I will wear you down. And what you do is you're going to tell me the area of that little rectangle. So I want you to think about this. You don't have to draw it out to the side. I just like to do that. What's the height of that rectangle?
F of X.
It's f of x. Okay, it's f of x because this is 0, whatever this would be, whatever y value that is, which is f of x, is the height of that rectangle. This is f of x. Now, this is the important part that I threw on you yesterday. What's the width of that rectangle? dx. dx just means delta x, which is the change in x. It's just a random, however wide that thing is, would be the change in x. Now, here's the beauty of this. The area of this rectangle, length times width, is f of x dx. And if I want to add all of the rectangles, it doesn't matter where I drew that rectangle. This statement is still the area of any rectangle under there. If I would like to add them all up, that's what the big S does. It's an S for sum, like SUM, sum. Add all of them up. We want to add them all up from where to where? -1 to 4. That sets up your integral for you. Do you see how there's a little bit less thinking?
Makes a lot more sense than what you said yesterday.
Okay, now, let's say we're going to simplify life again. Okay, so I'm going to give you the graph.
A lot better explanation than the abstraction that our calculator resorts to.
Okay, let's say we have this. Okay, and we're finding this area in here. Okay, we're going to call this pinky. It's going to be f of x. Doesn't matter. Okay?
B, or is it just like a very looking?
It doesn't matter. It's just a graph. I'll make it whatever shape you want on your paper. So 2 things don't matter. This is just for illustration purposes. Number 1, it does not matter if it goes below the x-axis. It doesn't matter. It will work itself out. I promise. You don't even have to think about it. Which is why you don't have to have a graph of it really and truly, as long as you know what's on the top. Now, if I make a slice, okay, make your slice.
Don't you know X values? Like-
Oh yeah, thank you. I was going to ask that. You have to know the intersection points. So let's say this intersection point is 2 and this intersection point is 5, just for the sake of whatever. Beautiful, Caleb. Now here's our slice right here. So I'm gonna pull out the rectangle. I would not do this if it was just my paper because I can write it on here. What's the height of this rectangle?
FX minus G.
Yes, it is f of x minus g of x. If you're like, I'm not sure, then this would be like, maybe pretend this is a height of 3 and this is a height of -1. You tell me what's the height of the thing. 4. How do we get that? We did 3 minus -1. F of x minus g of x. Top minus bottom, right? Top minus bottom, no matter what you've got. So this height is f of x minus g of x. What's the width of it?
Still
Still dx. That's my favorite question because it's an easy one. The width of that is dx. Now, if I want to add up all of the rectangles, I integrate
from 2 to 5.
f of x minus g of x dx from 2 to 5. Do you see how the slice kind of helps you?
A little bit.
Now, yes, Karen.
Is that slice like theoretically like really small?
Exactly. Right? And so that's where the whole idea of limits actually come back in. Because technically the definite integral is the limit as dx approaches 0. Right? Because you want that to be super skinny. Okay.
You have as little over underestimation as you can.
Correct. But because you're using the fundamental theorem, it takes care of it anyway. So it will be the exact value. Now, let me go back to, I'm going to go back to my graph from yesterday. Okay, now we're talking about sideways. Oh, that's terrible. Ugh.
So I should go back to my.
You can. Okay. I better just look at my graph.
You still have it from yesterday?
Yeah, but I wrote all over it. So,
We did too.
yeah. Okay, so here we go. It was y equals x. X equals y squared. And it was y plus 2. Okay. And then y plus 2 looked like this. More or less. Doesn't matter. We'll talk about like how do you going to graph this guy in a minute. We're looking for this area. We found where they intersected. It was at -1 and it was at +2. Okay, and we're going to call this guy x1 and this guy was x2. That's where we were from yesterday. Now, this is why I wanted to do it after talking to you about slices. If you were to slice this, okay, and this is not a criticism, we're used to making them horizontal slices, right? So if I make a vertical, if I make a vertical slice, I'm fine over here, right? That's going to be x2 minus, it's not though. Over here, though, I have a problem. Because this is subtracting from itself on the same graph. I cannot do that. Okay, do you see what I'm saying? Like, it's because it's not a function in this direction. So, therefore, we have to slice the other direction.
Okay, can you go back and say that again?
Yep. I can't slice it with a vertical slice because I would be dealing with the same function from here to here.
Yes, okay, I got it.
Does that make sense? Yep. Okay. So because of that, if there was no repeat in the same function, then I could do it, but I can't because of that piece there. So I have to slice it sideways. Okay, now I'm going to pull this out here so I can look at it a little bit bigger. So I'm over here. Now, I'm going to start with the easy one. What's the height of my rectangle? dy. Okay, that little skinny piece is going to be a dx or a dy. Now, I told you that is the most important thing, even though it's the smallest thing. Okay, I'll get to y in just a second, not why in just a second. what is the height of, or the width of this?
X1 minus.
I think it's the other way around.
It's x2 minus x1. And we talked about it yesterday, but I want to explain why. Because this is further positive, right? So it's, if we're working normal orientation, it's top minus bottom, but I'm not doing top minus bottom. I have to do right minus left because it's further positive. It's the more positive thing minus the lower thing. So this is going to be x2 minus x1. And I know that because this is the line, right? It's line minus curve in this case. So line is linear, curve is parabola. Now, if I want to add all of these up, I have x2 minus x1 dy. Now, before we do anything else, don't write anything because you're going to make some assumptions that aren't correct. This is the most important because it tells you two things. It tells you that your variables in here have to be in terms of y, because dy has to match, right? If it's dx, if it's x's, we use dx. If it's t's, we use dt's. This is dy. You have to have everything in terms of y. Yes. So I'm going to write mine differently, but you're correct. So it's x2, y plus 2 minus x1, which is y1. Now, if you want to reorganize them like Austin did, I would probably do that later because I don't like the way it looks. Now, here's the other thing. And this is, again, related to this. If this is dy and these are y's, then these two numbers here have to be y values. They are not x values, they're y values, which we found. When we set them equal to each other, we found where their y's are equal. So nicely enough, it came out as y equals -1 and y equals 2 because they're y values. So this would be from -1, which is the bottom, to +2, which is the top. Now you integrate them like normal. Your calculator will handle y's. So if you're like, oh, I can just put in my calculator with y's, you also could just pull a swap on your calculator and use x's and it will be fine. Right? Because your calculator doesn't care what letter you're using.
So long as you're consistent.
Yes, as long as you're consistent. As long as you don't switch it in the middle, okay? Now, so let's do, all I want you to do is, let me have you write.
Only work because we had a 1x on like the left. It was just like singular x equals y squared. What if we got more complicated with the x?
It has to be solved for x, or you have to be able to solve it for x.
So if there's like a circle, we can't do that.
Correct.
Well, the circle would be the same in the x and y, right?
Correct. Okay, so let's say we have this is going to be x equals y squared plus 4y plus 3. Nope. Sorry. Let's make him negative, negative, negative. So -y squared minus 4y minus 3.
So how do we graph these without
You don't.
solving?
Okay, so listen, you don't have to. That's what I will, and I will tell you why. Just a second. This guy is going to be I think x equals 2 minus y. Okay, now, so Joe's question is a good one. Well, how the heck am I going to graph this? Guess what? You don't have to. Okay, take a look at this. Tell me, let's name them. Let's name this x1 and x2. Okay, so let's do this together. Switch color. If I draw my slice, it doesn't matter if your graph is exact. It doesn't matter, right? Because you don't care what the graph looks like. You're doing all this without a calculator probably anyway. So what is the width of that? Length of it, width, whatever. What's the width of that slice? Yeah, in this case, x1 minus x2. So what you have to remember, the easiest way to do this is that a parabola upside down, right? Just turn your graph and be like, oh, upside down, parabola.
So make sure the positives end up, right?
Yes, positives would be up. That's the weird part about it.
We'd be given a graph and then have to decipher it.
Probably.
Okay.
Or not, but a negative parabola, there's your negative parabola. Yeah. Okay, so this is, you guys were correct, x1 minus x2. What's the height of that? dy. Now, I'm going to set it up a second. So I want to add up all my rectangles for x1, which is negative y squared minus 4y minus 3.
Martine, you are needed at the track, the upper gym. Martine, over to the track, upper gym.
For a minute, I wondered who Martine was. Do we have a French person now? Martine, you needed in the track.
No, she said Mert.
Thank you. Figured that out. No.
Your mom's just worried, so she wants to go too.
Okay.
Oh, she thinks it might be the man.
Okay, so you got this. Right? X1.
Every teacher with a kid walks out of their class.
X1 minus X2.
Okay, so we know what's happening.
Rock, paper, scissors.
We don't get time for that.
David, you're safe.
Okay.
David, we were worried about you.
Now,
Thank goodness.
why don't you listen to me, please? The only thing we have to figure out is from where to where.
Set equal.
Set them equal to each other, right? Well, you can always figure out where two things are equal if you set them equal to each other. So negative y squared minus 4y minus 3 equals 2 minus y. Now, this is a quadratic. What are you going to do?
Then I just have to one side.
Count your stuff to one side. Now, we're going to use our calculator because I'm afraid I've made some horrible errors and this doesn't actually factor. So I'm going to add y and minus 2. So we've got negative y squared minus 3y minus 5 equals 0. Use your quadratic formula program. So I'm pretty willing to bet that my graph isn't even correct, but it doesn't matter.
It doesn't work.
Are you freaking serious?
I did it wrong.
Yeah, I'm getting imaginary numbers.
I just got.
Okay, well, we're going to pretend that it did work.
The little eye there. Oh.
Yeah. So anyway, do you guys understand what we're supposed to do?
How do you have imaginary numbers on your calculator?
You use the one that's built into your apps. It gives you actual answers even if they don't exist.
Or you turn your mode to imaginary mode, complex mode. But don't, because it's not supposed to be
I just want
imaginary.
to look and see
Yeah.
what this is.
Anyway, it should have worked, but the process is the same. Do you guys understand what I'm throwing down here?
Looking up what you're laying down.
Do you get the idea of the slice? And that helps you when you are dealing with these sideways ones. So even, obviously my graph is not correct, which was my problem. That's why there was no point where they intersect. But give me a graph, make a sketch, figure out what one's going to be further to the right, and then go from there. Last thing I want to talk about, we were going to do this as a warm up, but so let's say we want the graph y equals natural log of x, y equals 1, y equals 2, and the y-axis. Okay, I want us to find the area bounded by these things. Now, happily, these are all y equals, so pop them in your calculator. Take a look at what that looks like. This is our last example. Now I'm going to give you homework time, which is phenomenal.
For one more day. Of course, I should take my test today. Then I would have been back in there. That's how confident I am in stuff.
Yeah.
Do they take those tests 3 days in a row back to back? I don't remember doing that.
Horrible.
I feel like you guys had
Did we do a Friday set? Did we do a Friday, Monday, Tuesday maybe?
I swear.
maybe like a 2 and a 1, like 2 and 1 or 1 and 2. I don't remember.
I would say I think the SAT was separate than the two.
from the other two.
I
Like
think
they
we
may
did
have
the-
done SAT and then the 2 PSAT days, and then you guys did the other two the
And then
next
work
week.
keys was later on.
Yeah, that's what I think so. So there's just flexibility in how you do it.
Why does why equals 2 matter if we have the y-axis? We don't see it.
Graphic.
So you said this was gonna be like our warm up?
This was like the warm up that we did not do. Avery,
Did you make your slice either way on
Oh,
those?
and why?
that is a great question, and we will talk about that in 2 seconds.
Wait, is this?
Yeah.
Don't we have to graph it so we know what it is?
So minor and very minor, minor and very
Minor and very. I know what, I'm pretty sure I already know what natural log of x looks like here.
So this one, it is really, because it's plus or minus because of the square root, it's plus or minus because it does go negative, but do I have to do this plus, because technically there could be a scenario where it would be positive?
This has to be true.
That has to be true.
That has to be true. So you can't have plus or minus, it has, you have to decide.
Does natural log, when does it become positive?
And so now that you've decided, let me tell you why. Because
I really
it's
see
either
what
the
I
top
think
half,
we can
which is
address
plus, or it's the
Oh,
bottom half, which
It's
is
one.
minus.
This way. I think I have the right I think I have the right answer. I'm not sure.
That's the graph.
I can't give you exactly how I got it, but I know that
Yeah, try to run the other one.
So if that
Looking
has
for that.
turns into
I can, this is actually good, I can talk you through that.
Okay.
But those, you are assuming those have to be true.
You're assuming those have.
Yep.
Right.
So what's the like?
Okay. So when you graph this, you get y equals natural log of x, which looks like this. We have y equals 1, which would be this. And we have y equals 2, which would be this. Okay, and we're looking for, this is that whole bounded by thing. The area bounded by these things has to be touching only those 4 things. Okay, so there's a lot of different regions here. There's only one that's bounded by all 4 of those though. Okay, and it's this. Right, there's the x-axis, there's the 2 y values, and there's the natural log of x. Now, this is Avery's question. He said, can I make the slice either way? So can you make a, whatever this is, vertical slice?
Yes.
What happens over here?
It's smaller, right?
It's just small.
It still touches.
But it's still 2 different
Yeah,
lines.
Is it not touching the,
Oh, does
that- the axis?
Because it's the
So,
same two things?
If you want to do, you could do this, you could do this both ways. I'm gonna show you. I would not do it both ways, personally. There's one way I wouldn't. So just listen, I'm gonna actually draw this on the board because I don't wanna mess with my drawing. Okay? If you draw it with a vertical slice, okay, you're gonna have to do it in 2 separates. Okay? Because here, what's the height of the thing? 1, because it's 2 minus 1, right? So you can do that and find the intersection point there and do that. And then over here, what do you have to do? What's the thing?
Y natural log minus.
No, it's 2
Minus natural.
minus natural log of x. You can do it that way. However, this is probably what I would do. I probably would make my slice this way because there's less math involved. However, I'm going to put this on the, I'm going to put this in there.
Gotta use like a line that's not on there.
No, you don't. A second.
Horizontal though, and it touches 3 of them at one time.
So if I go this way,
No, that's just like,
It's only
bounded by this, there's 2 numbers.
okay, what do the 1 and the 2 have to do with it?
They're like the numbers that go on the top.
Yeah, they're my boundaries. So I don't have to monkey with 2 integrals. I can only do it with 1, which personally seems easier to me. Now, here's the problem. What is the, what's the width of this? Nope, let's do this. What's the height of this? dy, which means that when I do this and I write, my variable has to be a y, which means what's the height of this? It's x, right? Because whatever the x value is here would be the width. I said the wrong thing. is the width. So you would have to solve this for x. But that's an easy solve. What is that? Right? E to the y. So this would be e to the y is my width. So e to the y dy from 1 to 2. Also, if I had to do this by hand, there's no way you're doing the other one by hand, right? Because you'd have to find that intersection point. You're not finding that. E to the y, what's the antiderivative of e to the y? If you had to do this by hand, it's the easiest integral in the world, right? If you had to use the fundamental theorem, then the antiderivative of this, just in case you've forgotten how to use the fundamental theorem, the antiderivative is e to the y, and you go from 2 to 1. So it would be e squared minus e to the 1. That would be your final answer. Just very easy and significantly easier than doing it in 2. Sometimes you will get ones where it's defined in terms of y and you can't split it up into 2 just because of the way it looks. Okay, so you have to solve it for x to go sideways. Okay, so I'm gonna give you your homework. You have the rest of the time to work on it, which is phenomenal.
Is it a worksheet?
It is a worksheet.
Why do I even say?
Caleb.
10%.
Caleb.